This is RollerCoaster Tycoon. It was released in 1999 and it was written almost entirely in x86 assembly. Because of that, Chris R managed to simulate complex physics along with 10,000 individual AI guests on a 90 MHz Pentium computer. Hardware is so limited, it would struggle to load a basic modern website today. For decades, the industry moved away from this level of efficiency. We've been living in the computational golden age, the so-called free lunch era. We did this because of Moore's law. For decades, microchips got twice as fast and twice as cheap every 2 years. Since hardware was practically free, the machine's performance didn't really matter, only developer time did. Essentially, high-level languages won. Why worry about language efficiency when Moore's law bailed us out every single time? And thus the era of move fast and break things was born. But Moore's law just hit a physical brick wall. Microchips have become so dense that we are reaching the literal limits of physics. Since 2004, the free hardware lunch officially ended. Software companies are now racking up record levels of server costs, spending upwards of $400 million per year just to run basic apps on the server, while user interfaces have slowed down to a crawl. I'm looking at you, Jira. But Google dropped a bombshell last month. They announced that 75% of all new code at Google is now AI generated, up from 50% last fall. That's the Google we're talking about. Yeah, they're using an internal LLM called Goose, trained on their own codebase, but that's a crazy rate of progress. At this rate, AI will be writing 100% of the new code in no time. But if that's the case, then why are we continuing to optimize for the human with high-level languages when we should be optimizing for the machine with low-level languages and reaping the performance benefits? And by the end of the video, you'll have an understanding of what kind of engineers will be obsolete and what kind will still have jobs, hopefully. The next logical step for the software industry is an AI-driven migration back to the metal, using AI to write high-performance compiled code to wipe out those multi-million-dollar server bills to a fraction of what they are today. This migration brings huge cost savings because high-level languages pay a massive abstraction tax to stay human-readable. They rely on heavy runtime interpreters to translate instructions on the fly. They use dynamic typing that forces the CPU to constantly guess data types, and automatic garbage collection algorithms that steal processing power to clean up dead data. When a company scales to a $400 million server bill, they are paying a massive premium just to keep that software middleman alive. But we can't do this yet for two reasons. First, there isn't enough low-level code on the internet for the AI to learn from. Second, the stakes are way too high. If an AI messes up in Python, the app just crashes safely. But if it messes up at the low level, it creates a hidden memory leak and massive security backdoors instead of a clean error message. That being said, frontier AI labs are bypassing this wall using compiler-in-the-loop reinforcement learning. Instead of just training the AI to mimic text, they hook the training loop up to a live compiler and test environment using algorithms like GRPO, Group Relative Policy Optimization. The AI gets an immediate, automated reward signal. Did it compile and pass? This environment effectively beats syntax and formatting errors out of the AI models. And to fix the data scarcity for ultra-low-level targets like Rust, Zig, or hardware-specific assembly, labs are deploying automated synthetic curriculum generation. Advanced AI models are being paired with strict compilers to mass-produce their own hyper-optimized, error-free low-level training data, scaling the data reservoir synthetically without relying on the public internet. But once the AI starts pumping out millions of lines of low-level code, we hit a lethal wall, the Watchmen problem. High-level languages like Python were explicitly designed to be readable by human eyes. Low-level languages are optimized for the machine, largely ignoring human comfort. Because of this, traditional human code review becomes more taxing. The codebase becomes an unreadable black box where no human engineer alive can realistically audit or catch subtle logic flaws across millions of lines of low-level instructions. Therefore, the old way of thinking about programming is dead. Since humans can no longer read or audit the underlying low-level code anyway, the human workflow shifts entirely to spec-driven development, like with SpecKit. The industry doesn't need people to type out code syntax line by line anymore. Instead, human product architects write airtight, unambiguous logical specifications, defining the exact inputs, outputs, and business rules, and the AI treats that specification as a new high-level language. And because manual line-by-line debugging becomes completely impractical at this scale, we must pivot our quality assurance to agentic testing. Instead of forcing tired engineers to read endless files to find a needle in a haystack, We build an adversarial red team of AI agents whose only job is to relentlessly bombard, probe, and try to break the system. If a fleet of AI testers attacks a piece of software for 24 hours and can't find a single vulnerability, that code achieves a level of operational safety that manual human review simply cannot match. But for mission-critical systems like aerospace, defense, or medical software, even aggressive testing cannot rule out rare cosmic events or rogue hardware anomalies where failure means loss of human life. Therefore, the highest stakes code will rely on formal mathematical verification using advanced frameworks like Kani. It looks and runs exactly like a traditional unit testing framework, but instead of executing a few random test inputs, it uses mathematical solvers to exhaustively prove the code is completely safe for every single possible input before it ever touches a physical microchip. But this doesn't mean human programmers are going away entirely. It just means the day-to-day job is shifting. Instead of spending your day writing out syntax or hunting down bugs line by line, your role moves to a higher plane. Humans become the system architects, the data seeders, and prompt designers who guide the core logic, managing the AI agents that do the heavy lifting under the hood. This doesn't mean high-level languages like Python or JavaScript are completely dead. They aren't going anywhere. But we are moving into a brand new era where whenever efficiency and server costs actually matter, companies will heavily prefer to let AI compile code straight down to the metal. The new high-level language isn't code at all. It is pure human intent, written in specifications, allowing us to build software at a scale Chris Sawyer could have only dreamed of.